Assalamualaikum warahmatullahi wabarakatuh. My name is Farah Natasha binti Zulkapli.
My name is Muhammad Huzaifah bin Azmi.
My name is Nurina Bila binti Jamil.
First, I will talk about the introduction of our study, where there are certain highways that have flaws in their design or hazardous paths that increase the collision. Therefore, Google Map, Apple Map, and Waze are the examples of current navigation system that recommend the quickest route from one destination to another destination. According to Papinski and Scott, 2011, a real-world GPS dataset of 237 home-to-work journey, they discovered that drivers chose routes that are much longer than the shortest distance, as they preferred the routes that are based on their knowledge rather than lost in a traffic jam. This issue might also include cold storage transportation, as green and healthful products have increasingly become the key criterion for customers when it comes to selecting fresh meals. According to Mazurski and Rayner, different approach may produce different results. Therefore, it is vital to evaluate various of multi-criterion decision-making procedures according to the choice of problem. Next is our problem statement, where drivers have difficulties in choosing the routes as their decision is based on their knowledge solely. Therefore, it leads on delaying the goods, where the distribution of the goods may affect the product quality, especially the greens and healthful products, as it must be stored at a certain temperature. The objective of this study is to determine the safest, shortest, fastest path among the alternative routes using TOPSIS and fuzzy TOPSIS. Next is to compare the result of fuzzy TOPSIS and TOPSIS using Spearman rank correlation. Next is scope and limitation of this study, where cold storage vehicle routing using TOPSIS and fuzzy TOPSIS method, because it is the most known technique for solving MCDM problems. This method also applicable to develop a high-quality solution under uncertainty. And for the limitation, the time taken from one destination to another destination is not constant, as we must consider the traffic along the route. Next, the safety level is solely based on the driver's knowledge who have used the route before. And for the significance of this study, it is to offer a solution for evacuation of route planning method. Next is provide safety evaluation techniques that may reflect changes in road safety conditions.
The table shows the summary of safety road research. Kazimierz John Rose 2008. In his research, he illustrates the history of road safety concept and ideas. Ying Zhang and others 2021 proposed a practical procedure for assessing the effect of road safety treatment using weighting method. Waterway and others 2020 in their research to determine whether there are any links between country culture, road safety performance, and popular support for policy initiatives. Next is the summary of TOPSIS mathematical model. Hushi and others 2007 in their research to investigate how to apply TOPSIS in the actual world. Eventually, and Henri Accuse 2018 aim to present a complete NCAM method for choosing a suitable shiploader type. R. Michael and others 2017 in their research they aim to find a solution for vehicle problem routing that minimize the travel cost. Lastly, the summary of fuzzy TOPSIS mathematical model. Sorin and others 2016 aim to provide a broad overview of evolution of fuzzy TOPSIS approaches. Pascal Yuonu and others 2017 in their research using fuzzy TOPSIS to aid the selection of sustainable acid rain control alternative. Bakir Sahin and others 2020 using a fuzzy technique for order preference by similarity to ideal solution.
Our research process consists of a few steps based on the flowchart. First one is data collection. Data were collected by using questionnaire and were distributed to the driver by using Google Form. The second one is secondary data of travel log of a lorry that contains information about the destination of transportation. The third one is Google Maps. We use Google Maps to estimate the distance and time of the transportation. Secondly, matrix preparation. The responses from questionnaire were analyzed for the safety level of each route taken. The average of safety level were then taken in order to form a matrix. The matrix is decision matrix, where we form using Excel to calculate each criterion. As for the decision analysis method, there are two methods, which are TOPSIS and fuzzy TOPSIS. First thing first, we go through the first decision analysis method, which is TOPSIS. Step 1 is normalize the decision matrix. And step 2, calculate the weighted normalized decision matrix. And step 3, determine the positive ideal and negative ideal solutions. And step 4, calculate the separation from positive ideal and negative ideal solution from each alternative. And the last step, we need to calculate the relative closeness to the ideal solution. Next, we proceed with the second decision analysis method, which is fuzzy TOPSIS. The first step is construct combined decision matrix, where A, B, and C are fuzzy numbers. For the step 2, aggregate the weight of criteria and ratings of alternatives given by K decision makers. And step 3, construct normalized fuzzy decision matrix. Step 4, we need to construct weighted normalized fuzzy decision matrix. And step 5, construct fuzzy positive ideal solution and negative ideal solution. And for step 6, we need to calculate the distance of each alternative from fuzzy positive ideal solution and negative ideal solution. The last step is calculate closeness coefficient to determine the ranking order of alternatives. And finally, experiment strength correlation we use to measure the strength and direction of association between TOPSIS and fuzzy TOPSIS.
First, we will discuss about the calculation using TOPSIS model. Table above shows the positive ideal solution and negative ideal solution for TOPSIS model. The value of positive ideal of distance and time taken are based on the minimum value from column distance and time taken of weighted normalized decision matrix. Meanwhile, for the safety level, we choose the maximum value. We chose that values because in the best path selection, the shortest distance and time taken and the maximum level of safety are preferred. The value for negative ideal are opposite from the positive ideal, which is the maximum value for distance and time taken and the minimum value for safety level. This table shows the result of relative closeness to the ideal solution. Second, we will discuss the calculation using fuzzy TOPSIS model. The table above shows the result for fuzzy positive ideal solution (FPIS) and fuzzy negative ideal solution (FNIS). The value selection of FPIS for the three criteria, distance, time taken, and safety level, are similar with the value selection in positive ideal solution of TOPSIS model. Same goes to the FNIS. This table shows the result for closeness coefficient to the ideal solution for fuzzy TOPSIS. The table displays the root rankings based on the relative closeness coefficient of TOPSIS and fuzzy TOPSIS. Both methods shows the same rank for each root, which is L4 at the first rank, L2 at the second rank, L1 at the third rank, and L3 at the fourth rank. Based on those ranks, it indicates that L4 is the safest, shortest, and fastest path in this research. From the plot figure, we can see that the methods are perfectly linearly related.
As a conclusion, cold storage transport always emphasize that the goods must be delivered to the customers at a certain temperature. And from the result, the fourth route, which is from Selangor, Bentong, Kuala Krai to Kota Baru, confirms that it is the best route to achieve our goal as it has the highest coefficient correlation, which is 1. And for recommendation, the future researchers can study about route planning on transportation using analytical hierarchy process (AHP). Next, they can use Safe Route Planner where it considers the risk of accident in evaluating security rating of routes. That's the end of our presentation. Thank you and have a nice day.